partnership as a badge of honor. We're not just experts, we're enthusiasts, committed to harnessing the full potential of Microsoft technologies. And as a pure play Microsoft partner with a team of dedicated UK engineers, from app innovation, to, supporting pro code, no code, low code, to data and AI, Azure security, we equip to support a wide range of Microsoft solution day in and out. So throughout the next 40 minutes or so in this session, we're eager to share our knowledge and insight on this particular topic today, which is app modernization. And we're equally excited to hear your thoughts at the end of the session or further discussion. So without further ado, let me pass you over to my colleague, Peter.
Good morning. I'm Pete Lutchard. I'm a technical architect at Transparity. Joined Transparity in 2022. I work exclusively on Azure-based solutions across many different industry sectors, from utilities to financial services. So we're going to talk about app modernization, but what does that mean? So I wrote my first computer program about 40 years ago on a Sinclair ZX81 using BASIC. I learned Pascal at school, and they're still using Fortran 77 when I did my science degree. I've been working in software development for about 24 years now, and I can say that the development landscape has changed very significantly, but possibly more in the last 5 years than in the preceding decades. 25 years ago, the buzzword was RAD, which stood for Rapid Application Development. And it was about getting software built and into production as quickly as possible. Testing was seen as a chore. Security was often not a consideration. But since then, the software industry has matured and modern apps have developed with resilience, stability, scalability, security, and maintainability at the core. And this webinar is about how we achieve that. Now, I'm going to start by talking a bit about how we approach Azure, how we start on the journey towards developing modern apps. So I hope to explain what that actually means and to talk about modern approaches to development. I'm going to spend a bit of time talking about some of the essential tools that we have to make all of this possible. Hope to give a couple of quick demos to show you some of the tools in action. And I'll cover some of the breadth of Azure offerings and then go on to talk about some of the modern app concepts such as containerisation and serverless computing. We've got a bit of time at the end, as Jonathan said, for questions and answers. So if you want to post any questions in the chat window as we go, I'll have a look at those at the end and try and answer them all. Okay, so the first step in the modernization journey is to enable our customers to use Azure, and that's a very simple step which Transparity can help with. It might be that you have existing solutions running in on-premise servers, and so the next step in that journey might be to migrate existing systems to Azure. Again, that's something we do at Transparity every day. But the final part of this journey is to adopt the cloud-first approach, and that's where all new apps and solutions are developed for the cloud. And that's the part that we're going to focus on today, and that's a part of the journey that we in the App Innovation team deliver. So, modern application development. Well, there's three different approaches that I'm going to mention here. The first approach is low code cloud applications. So these essentially self-serve tools or extensions that allow you to create your own apps in Microsoft 365, Power Apps, Power BI are examples. They don't require a huge amount of learning to master. And what you can do is it allows you to create quick, yet simple, yet powerful apps. That's not what we're going to talk about today, but it's one aspect of modern applications. The next one is cloud business applications, or biz apps. Now, these are large, fully featured applications such as CRM systems. But they're also modern apps. They're customizable, they're scalable, they're cloud-based applications with fully featured APIs. And again, that's important part of modern applications, but it's not what we're going to focus on today. What we're going to talk about is building new, fully bespoke applications for the cloud. So let's have a look at a quick history of app development over the last 30 years or so. Originally, we started with big mainframe machines, or large monolithic applications that did everything. Then as hardware and infrastructure allowed, systems were split into client-server architecture, then three-tier architecture where data, logic, and presentation were split into separate applications. That architecture was supported by new communication protocols such as SOAP and then REST. Then everything went mobile. And next was the microservices architecture, where every function of the solution is split down into lots of mini apps, each with its own clear role and the ability to be independently deployed, configured, secured, and scaled up and down as required. Containerisation provided a solution for rapidly scaling up applications with varying load. And the last part of this journey is serverless computing, which allows developers just to push code into the cloud and delegate the management of that infrastructure totally to the cloud. So in terms of infrastructure, there's been a move from physical machines owned and managed by the user's organization to virtual machines, which can be duplicated to support differing demands on load and for things like disaster recovery. Then cloud infrastructure, and when I'm talking about cloud infrastructure here, I'm talking about virtual machines in the cloud. What that did was remove the need for hardware ownership and provided automation of maintenance tasks. But you're not really fully leveraging the power of the cloud when you do that. So the final stage, and this is where we're trying to get to, is born in the cloud. So this is apps developed in the cloud, for the cloud, hosted in the cloud. And all the big modern apps, the Googles and Facebooks and the Microsoft apps, are modern cloud apps, all following this modern pattern of application development. So, how do we get there? If you're starting with a large on-premises solution, the option of a complete rewrite of that application just isn't practical. So maybe you've got a desktop application distributed, among your organization, or something hosted on-premise servers, or you've got a dedicated box in a data center. So the first step could be to move that application to virtual machines in the cloud. And at this stage, you're not rewriting the application code. And it addresses, again, as I say, the cost of ownership issues, improves resilience and disaster recovery. But again, you're not really harnessing that power. The next stage might be to pull that application apart, to use containers to create an end-tier architecture and this stage we're still talking about sort of minimal code changes. But ultimately you want to move your application to a microservices architecture, excuse me. Where you break down the services into smaller services, as I say, with a clear function and a simple interface between. And this aids testing, fault finding, and the continual introduction of new functionality, as well as scalability. So you might have one part of the application that's very busy for 1 hour between 9 o'clock and 10 o'clock in the morning, say, but the rest of the application is not doing much work. Do you really want to scale up your entire solution resource? So what we're seeing in modern solution design is a move away from large, complex, monolithic applications to a collection of small, simple, scalable services, communicating with each other across super fast fiber connections within a data center. And those services themselves are consuming other services. Some of those services may be bespoke to the solution, but others may be out-of-the-box services available through Azure. And as developers, we want to take as much advantage as possible of the existing services that Azure provides. And we'll take a look at that enormous range of available services in a few minutes. So for those of us who worked in the world of software development for a couple of decades, we need to understand why we're making these changes. Otherwise, it just seems like change for change's sake. The large monolithic applications of the past were easy to deploy, to secure and maintain. So why would any sane developer replace a single application with dozens of applications, each requiring separate deployment, authentication, configuration, and maintenance? I mean, that sounds like a nightmare, or would have done a few years back. So the benefits of that scalability and isolation are obvious, but it's only really recently become possible thanks to improvements in automation, deployment, and configuration through tools like DevOps and also technologies such as containerisation, serverless computing, and the powerful management and monitoring tools that are available in Azure. So let's have a look at those tools that we have available for modern application development. So we're moving to a state where we're developing in the cloud and for the cloud. And Azure provides more than just infrastructure. It provides a complete development platform as a service. Not only databases, storage, website infrastructure, but also source code repository, sprint management, build and deployment pipelines, backlog management, bug tracking. All of this built into DevOps and that development platform, and those platforms themselves sit on top of infrastructure as a service. Modern app developers use these cloud tools to develop cloud apps, and one of the most important platforms in development is DevOps. So we're going to dive into DevOps in a bit more detail. So DevOps evolved over many years from Team Foundation Services, which was a client server architecture, before fully moving into the cloud and becoming Visual Studio Online, and then expanding into the fully fledged development platform that it is today. One of the many features DevOps provides is backlog management. It supports different approaches to managing development, such as Scrum or Kanban. In a screenshot here, we see a backlog divided into epics, and those epics divided into features, and features are divided into user stories. And you can further divide those. You can include tasks and bugs and issues, and how you want to structure your project in DevOps is very much dependent on how you as an organization work. But what this enables you to do, and we'll look at that in a bit more detail in a second, but it's an aid to project management and resourcing. We'll come back to that in a second. But other than the sort of sprint management and backlog management, DevOps provides a source code repository using Git, which is now owned by Microsoft, and that provides branching and merging to enable simultaneous development by either small or large teams of developers. Another powerful tool that's available in DevOps, and this is the one that allows us to implement the microservices architecture, is the build and deployment pipelines. Now, what these allow you to do is set up automated tasks such as builds, code sanitization, testing, running PowerShell or SQL scripts, deployment and configuration. And configuration items such as logins or secrets themselves can be secured in Azure Key Vault or hidden in pipeline libraries, so that they're obfuscated from DevOps users and in any deployment logs. So it's a very secure way of actually deploying applications. There's no secrets or logins that are downloaded onto developers' machines. And pipelines allow applications to be deployed to multiple environments, so development, testing, production, or even multiple regions. You can configure optional gates, such as a requirement to pass automated tests, a requirement for a code review by an authorized team member, requirement to link every single code change to a specific backlog item, just to make sure people aren't checking in code changes which haven't been already approved. And of course, there's you can put in an approval gate to ensure that one or more authorized people authorize the deployment to production. The pipelines themselves can be triggered automatically in response to certain events, like a request to merge code by a developer or the completion of a merge of code. Often pipelines are set up to run every night to ensure that any code checked in by developers during that day can build and passes regression testing. So a developer can make a code change, check that code change into the source code repository, and a bunch of tasks such as builds and tests can then run. Notifications can be sent, a new version can be deployed to a test environment, and all of this is completely automated. So another cornerstone of automated development is infrastructure as code. The entire infrastructure of your solution can be represented in an Azure Resource Management template, or ARM template, ready to run in the deployment pipeline. The template is written in JSON code, and it defines every microservice or Azure service that's required for the solution, and where it should be deployed. So it can be used to deploy copies of the solution to multiple nodes in different regions across the world, or it could be used to quickly stand up a complete solution in a disaster recovery scenario. ARM templates make that process of making a small update or a bug fix to a large solution deployed in multiple regions as simple as running a pipeline. So going back to what I was talking about, the change from years ago in those monolithic applications, you think about this infrastructure sort of nightmare of rolling out an application with dozens of different parts to it, each secured and configured differently in a dozen regions around the world. And now it's something you can do at the click of a button. So ARM templates aren't the only supported infrastructure as a code solution. There's a scripting language which some joker at Microsoft decided to call Bicep instead of ARM templates, and that does the same thing, but it's slightly easier to use for developers who are used to writing programming code. There's a third-party solution. There are multiple third-party solutions. Terraform is another one, which is cross-platform and has slightly more intuitive syntax. But a bit more on pipelines. This is an example of what a deployment pipeline might look like. So there's a nice sort of visual tool within DevOps for generating these. You can define a trigger. In this case, the one on the screen is manually triggered. You can define multiple environments for the development. They're either linked together, so it deploys to one and then the next and then the next, or you can put an approval gate between those different environments. You might be deploying app services or database schema changes, or deploying a container to Kubernetes. And then each of those stages shown there can consist of any number of deployment tasks or scripts. I'll show you a bit more on that later. So this shows the visual tool, which makes it quite simple to pull these pipelines together. But there's also a scripting language called YAML, and that can be used to create those if you need greater control. So let's have a quick look at what DevOps looks like. So I'm just going to share my screen here. Okay, so I mentioned earlier we've got these tools for managing backlogs, and we get things like epics and features and user stories and bugs and so on. So this is what your backlog might look like. So we can then organize our development into, let's say, 2 or 3 week sprints. So we can go here in DevOps and we can set up our sprint. We can set the dates for that sprint. The sprint we're going to call iteration 2. We've pulled in a few of our developers here. We've decided what activity these developers are involved in. These are developers. They could be testers. They could be involved in design or deployment. Their capacity per day. We can put in their holidays as well. So when we come to calculating resource for this sprint, actually what we can do is we can take into account what hours people are working. Maybe someone's part-time, what days they got off, what days, what put in bank holidays, and so on. And then when we go back into the backlog, let's have a look at some of these tasks here. We can set up the activity. Is this a development or a testing activity? We can put in an estimate in number of hours. We can put in the state of that. We can assign that to someone. So we might want to say assign all these 3 tasks here to one of our guys. This guy Pete Lutchford, he's a good developer. Let's assign it to him. Then when we go into and look at our sprints here in this view here, we can have a look at the capacity. We can see 16 hours are assigned to Pete Lutchford. Well, I can tell by looking at that we've got plenty more time available there. And there are various views and dashboards you can create, so you can look at the amount of available time, and then you can see what you can squeeze into the current sprint, who's a bit short on work, who's a bit over capacity, and so on. There are various views you can have here. There's a task board. So here's a list of all our tasks. When I finish this one, I can just drag that into, or when I start it, I can drag it to active, and the status changes to active. Notifications are sent out to anyone who's set up for notifications. And when I finished it, I can drag that into a resolved or a closed state. I mentioned pipelines as well. Let's have a look at this pipeline here. This is our DevOps demo pipeline. If we edit this, again, we're using our visual tool for building our pipelines here. We've got a number of tasks. We're installing the npm. We're doing some code sanitization. We're doing a build. We're running some automated tests here. We're publishing the application files here. And this can be set up with, as I say, automatic trigger to run on certain events. And we can go in here and we can have a look and just see that pipeline's run successfully. And if it errored on one of these stages, we can go in and have a look at this log and see what the problem is. So let's just pop back to our presentation. So we can't really talk about tools for app development without giving a bit of a mention to Copilot. So this is something fairly new, and it could be a game changer. So Copilot is like a sort of AI buddy coder. Now, whereas Copilot isn't advanced enough to design whole systems from scratch, and nor, to be honest, do I think it ever will be. And it's an immensely powerful tool to programming, an immensely powerful aid to programming. So what it does, as you're typing code as a developer, it's making suggestions the whole time, and those suggestions are based on a massive library of code in open source, GitHub, and places like that, but also in your current solution. So it's really good for generating boilerplate code, things like unit tests. It takes a lot of that legwork out of development. But not only that, it's a bit smarter than that. It can generate quite complex code. So stuff that as a developer you might otherwise need to sort of look up and on Google, maybe your SQL queries, you might think, oh, I can't remember how to do that, or maybe something like regular expressions. Does anyone actually know regular expressions? But of course, Copilot has access to massive libraries of this stuff, so it's very fast at doing that kind of thing. But what's really good about it, it doesn't just find a bit of code in GitHub that someone's written, which it thinks is appropriate, and squirt that into your application. It actually proactively blocks insecure code and prevents any code that contains known vulnerabilities from going in. And again, it's using an AI algorithm for spotting vulnerabilities in code. So as a developer, couldn't really do a webinar without showing a little bit of code. So let's see if we can do a quick demo of Copilot, just to give you a bit of a flavour as to what it works, as to what it does. Now, got to warn you with any AI demo that results are never 100% predictable. Most of the time, Copilot makes good suggestions, but every now and then it comes up with something that's not so helpful, and it's down to the developer to pick and choose what's helpful. So let's put some code on the screen here. Okay, so this is a simple repository class, fetches some data from a database, and this is an application actually for intercompany billing in the utilities industry. The data we're looking for here is an electricity tariff, and the tariff has an effective from and effective to date. And what we want to do is we want to look up a tariff based on something called a line loss factor class. Now, Copilot has absolutely no understanding of the utilities industry, but it does understand programming code, and it doesn't understand English. So I'm going to go ahead. I'm going to put a function. I'm going to put a new function in here. I'm going to write, as any good developer would, a little comment before I start that function. And bear in mind, Copilot has no idea what I'm about to do. But I'm going to start typing a comment. Here we go. That's function to return. And here we go. Like straight away, it's suggesting what comment I might want to put in. Well, that's pretty close. It's not quite what I want to do. So we'll carry on. The more I type, the better the context. To return the current tariff record for a given LLFC, line loss factor class. Well, yeah, that's right. It's not quite right. So Copilot, good effort, but I'm gonna carry on. I've hit the space bar, and now Copilot's suggesting and date. Well, that's actually exactly what I want to do. So I'm going to hit tab to accept that. I'm going to start writing my function. But before I even start writing any code here, Copilot has suggested this function. So this grey text here is Copilot suggestion. Get current by LLFC and date. So actually that's correct. But not only is it correct, it's using the same sort of naming convention that I've used in the rest of my code. I'm calling line loss factor classes LLFC. I'm using I'm using asynchronous coding, and it's put in a public asynchronous task for this function. So it's doing a little bit more than just sampling code. It's adapting that code to fit in with the current solution, to fit in with the current architecture, to adopt your coding standards, and all of that's happening in a fraction of a second as you type. Let's pop back to our presentation. So, monitoring. This is something that's often neglected, but it should be as an essential part of every modern app. Azure provides access to a huge amount of application metrics through application insights and Azure Monitor. And here's an example for a web app. You can see things like response times, failed requests, server errors, CPU usage across any time period, and you can create your own dashboard view. It allows you to see when something's going wrong, or just give you a picture of the distribution of load across the system throughout the day. If you see that CPU usage is hitting 100% and response time is going up at certain times of day, well, that's an indication that the system is under-resourced. And we'll come to what you can do to mitigate that problem once you've identified it in a minute. Of course, it's no use having all these metrics without some sort of notification system. So you don't want to pay someone to sit there watching these graphs all day. Azure Monitor allows you to set up various types of notification based on metrics. So you can be alerted, for example, if response times go above a certain threshold, or if you get more than a certain number of server errors within a set time frame. And the metrics and thresholds for alerting need to be considered right at the start of your project in the solution design. So I mentioned that there's a huge breadth of services available in Azure. So databases, storage, app hosting, built-in authentication and identity services, networking, containerisation. We don't want to create our own database system or our own identity provider or our own AI search. We want to build our solution to consume an existing Azure service. And there's a service for everything. This here is a tiny fraction of the number of services available. It's just to give you a little idea of the breadth of those services. So we have app services here. This is for hosting applications, web apps, or even APIs. SQL Azure is a lightweight SQL Server instance. It's easy to manage, but it can be very cheap as well. There's various licensing options which can be based purely on usage. So if you've got a database that's only busy for a few hours a day, it can be a very cost-effective option. Similarly, if you've got multiple databases with different patterns of usage, there's an option called an elastic pool, where you just pay for the overall resource consumption, regardless of the number of databases. Azure Cognitive Search, very powerful AI-driven search functionality in there. Azure Storage for files or tables, and there's some message queue functionality in there as well. Azure Redis for caching. API management allows you to balance calls to APIs, distribute APIs, manage security, and so on. Cosmos DB is a NoSQL alternative to SQL Server. If you've got a lot of non-relational data, it's a very fast and efficient alternative. Azure AD has now been renamed to Entra. Is a complete identity platform, so either business to business or B2C. Service Bus provides very fully functioned message queuing functionality, and so on. It goes on. And there's a lot of AI tools available, such as a bot service, cognitive services for analysis, but also, things like the bot service is great for things like sort of technical support, and so on. So, as I said, we want to make the most use of the existing services that are available. So rather than create a single monolithic application that provides all the functionality our solution requires, we create many small services that consume other services, each performing a simple discrete function, which together form our solution. That's the microservices architecture that we're aiming for. And so we want to make the Azure services do as much work as possible and create apps really that do as little as possible. And that's why it's so beneficial to have that huge library of Azure services. So I mentioned earlier that Azure Monitor can help us identify when a system's under-resourced. Here's a solution to that problem with a real-life example. So we've got an API here which is responding to multiple mobile devices, and the problem was this was originally hosted on IIS, I think, in a data center, or VM in a data center. But it wasn't scalable or resilient, and what was happening in certain times of day, there was a massive peak in usage, and other times of day it was very quiet. So the solution is to use the auto scaling capability of Azure. So what we have now, we've got it automatically set up to scale out whenever the average CPU goes over 60% or something like that, or the memory reaches a similar threshold for a specified period of time. So when that happens, Azure creates another copy of that application, and then it manages the load balancing across all those running applications. So it might take a minute or two for that application to fire up, but when it's ready, then instantly that load gets balanced across that. What we see in this graph on the right here is the number of instances of this application over a week. So you see that it's going up to about 10 instances at peak times on weekdays in the mornings. At night time, there's one instance running, and weekends there's very little activity. Once 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 you can define your metrics for scaling up or scaling out rather, but also you can define metrics for scaling back in. So when the CPU usage falls below a certain level for a certain number of seconds or minutes, and when the memory usage starts to drop again, a rule can be implemented whereby one of those application instances is then decommissioned. And because billing for most of these Azure services is actually based on resource consumption, it means that auto scaling in and out is far cheaper than actually just providing enough resource 24/7 to cover the peak times. SQL Azure again has a similar approach. So what you can do with SQL Azure is define the number of virtual CPUs you want your database to use, and then it will automatically just scale up and down as needed. So again, we've got a chart here of the number of CPUs in use in the period of a week. So on weekdays, during office hours, it's SQL Server is realizing that it needs to kind of scale up to use, I think, something like 12 CPUs there, and then it just brings them back down when it goes quiet. So another option for scaling out is containerization. So the idea behind containerization is rather than spinning up a VM, what you can do is spin up a container, which is like a lightweight VM with a lightweight version of the operating system with only the stuff that you need to run your specific application. It's very quick to spin up, and it runs very efficiently. So Docker is the sort of underlying technology that makes this possible. You can deploy using your automated pipelines in DevOps. You can deploy your solution, you write your web application or your API in any language, and then deploy that into a container. And that container image or that app image is contained in something called a container registry, and the Azure version of that is the Azure Container Registry. So that defines the copy, the image of that container. So as and when you need to scale out and create more containers, another copy of that container from the registry is produced. So originally, when Docker came along, you used to run it via sort of a command line interface on a VM. Then tools like Docker Compose and Docker Swarm came along. Microsoft had provided something called Azure Container Instance, which is another way of starting up, running, managing containers. So you don't have to worry about a VM, and don't have to worry about sending Docker commands. That handles it for you. If you have a very large, complex solution, then you need slightly more complex orchestration of all those containers. You need to if you need a bit more control about how many containers you're producing, and you want detailed monitoring of that process. AKS or Azure Kubernetes service is a service for managing complex container solutions. It's divided up into nodes, which are essentially VMs, pods, which are typically a container, each containing one instance of your application. Deployments, namespaces. Then there's a control plane that exists that allows you to manage the running of those containers. All of these parts are responsible for running your container cluster. AKS is quite a complex system to use. So it's really only appropriate if you have very complex solution and you want a lot of control over how that runs. But what if you don't have a complex solution? What if you just, as a developer, just want to push code into the cloud and say run it, and then let the cloud infrastructure manage it? If you don't care where it runs, you don't want to bother with containers and virtual machines. That's where we go into the world of serverless computing. So no VMs or containers to worry about. Just push the code and let Azure deal with it. So there's a couple of examples of that. And sorry, I'm running a little bit over, so I'm going to whiz through these quite quickly. Azure Functions. Literally, you can just push code into the cloud, and you can write that code in it supports a number of different languages like JavaScript, C#, Python, Java, even PowerShell scripts. You define a trigger, so it might be a timer. You might have a function that you want to run every 15 minutes, or it might be something that responds to an HTTP call. When that function's triggered, somewhere on a data center, some code runs and does its thing, and you don't have to worry about where that happens. What you can say is, I want to create up to, say, 200 instances of that function. I'm going to be hitting that function with millions of calls, and I want you to spawn as many as 200 versions of that function, and Azure will do that for you. That's called the consumption model, and it's very cheap. You get something like 1 million calls for free each month. If you have longer running functions, you have something called durable functions. You can deploy these to an app service, and they're permanently on. So it's a slightly different approach, but it allows you to run functions over a long period of time, and there isn't that startup slight delay that you have with the consumer plan, where yes, your trigger fires, but you've still got to wait for that code to be loaded into a computer somewhere. And the durable functions, you can run your function within an app service. It's a slightly different billing model, but it means that function's always there. And again, you've still got that option for parallel processing to run multiple functions at once when things get really busy. And then lastly, I'll very quickly cover logic apps. So logic apps they've become like a replacement for BizTalk server. You can create quite complex workflows using a visual tool in the Azure portal. There are various triggers, again similar to functions. Lots of different connectors to things like Dynamics 365, SAP, Oracle databases, and they're great for sort of system integration scenarios. So you can build quite complex workflows with various kind of tests and if conditions and so on. You can pull data in from one of your connectors and then push it out, transform that data and push it out to another connector. And again, like functions, you don't have to worry about where it runs. You can just create that through your visual tool in the Azure portal, and tell it how many times in parallel you want it to run. Maybe just once, maybe you only want a single instance, or maybe you want 100 instances. And again, it's a very cheap way of running code. So let's just quickly look at the key takeaways from this. I'm gonna stop talking and hand over to John in just 1 second. Cloud first. So develop in the cloud for the cloud. Develop independent small microservices. Break your application down into as smaller bits as you possibly can. Consume existing Azure services wherever possible rather than developing your own. Use services or containers, not VMs, to get the full power of auto scaling. Automate the deployment using pipelines. Use ARM templates, Bicep, Terraform. Don't deploy individual applications manually. Automate your testing. Unit testing and system testing can all be scripted up and automated and run through your pipelines. And don't forget monitoring. Monitoring is key to the success of running your application. So I'll have a quick look if there are any questions. If you'd like a bit of an assessment of what options there are within your organization for us to help you, do get in touch. There's going to be, I think, a link in the chat window, or get in touch with John. So I'm just going to have a quick look, see if we've got any questions here. How are we doing for time, John? Are we all right? Can I?
We're good. Yeah, Peter, thank you for that. I mean, it's great information that you share with, I've learned a lot today, as well as I'm sure some of the audience here on the call. So like what Peter said earlier, as an organizations, we are aware of many different these toolings and, with application modernization. So if you guys are on a journey right now that like to have a bit of support from a partner like us, feel free to reach out to us. We do have, bandwidth to be able to have a one-to-one session with you guys, carrying some assessment into, sharing, having you to share with us your current state of your applications. So, feel free to reach out to us, leave us your contact detail here on chat. If not, directly, reach out to Transparency Group, and then we can arrange a time and further conversation with you guys on that particular part. So yeah, let's see if we got any questions, Pete. Anyone got any questions?
Excellent. I obviously explained it all very well. But do come back to us later with questions if you have any. We've got a white paper on Copilot as well, haven't we? I think
we have, yeah.
We can share a link to that at some point.
So what we can do is probably, after this webinar, we'll be able to kind of reach out to follow up with some white papers, and then we'll probably see if you guys like to have a more in-depth conversation with us. We'll give it another minute to see if anyone got any questions. If not, we'll just wrap it up for the session. I think we're good. All right. Thanks everyone for joining us today. And we look
Thanks,
forward
Pete. Thanks, Johnny.
Have a further conversation. Thanks.
It's been a pleasure. Okay.
Cheers.
Bye now.